Good morning, everyone. I just wanted to go through this 4.4 notes with you so that you can get through these examples and hopefully be able to start on the homework for Monday. So if you haven't already, take a look at this page 189, the multiplication counting rule. This is the first one of our counting methods, but I will show you this next example that uses this method. So in this case, we're looking at how many possible ATM PIN codes could there be if each PIN has 4 digits. So the way you want to think about this is you're basically selecting 4 different values, and I always write these out by drawing out, like in this case, 4 sort of blank lines on my paper and say, okay, for each one of those 4 digits in a PIN code, how many possible options are there? And this is how the counting rule works. So for an ATM PIN code, we're looking at the digits 0 through 9 for each option. So that's 10 possibilities. So there would be 10 possibilities for the first one, 10 for the second, 10 for the third, and 10 for the fourth. So what the multiplication rule or the multiplication counting method tells us is that if you have these sort of repeated selections with a certain number of options in each one, the total number of options is just the product of all of those possibilities. So in this case, that would be 10 times 10 times 10 times 10, or one with 4 zeros or 10,000 possibilities. So there are 10,000 possible ATM PIN codes. Now, one thing that's unique to this counting method is that in this case, we said we could use the same number multiple times. So you could have like 2 ones in your PIN code, for example. If for some reason you didn't want to allow repeat digits, so maybe your PIN code had to be 4 different numbers, you could adapt this method and do the same thing, but while we would have 10 options for the first number, we would only have 9 for the second, 8 for the third, and 7 for the last, taking into account that we're sort of reducing the number of options. So counting rules can work with that as well. They don't have to all be the same number of possibilities. Another classic multiplication counting rule problem is if you're selecting outfits and you say you have 5 different shirts and 3 different pants and 2 different pairs of shoes. We would take 5 times 3 times 2 to get the total number of possible outfits. So that would be another example. Okay, there are 2 other counting methods that we'll look at in this section. The first one is called permutations. The second one is called combinations. So a permutation is actually kind of related to the multiplication rule, but the whole idea here is that we're selecting are different things or people or whatever we're talking about from among n possibilities. So n represents how many total options you've got, and r is how many things that we want to pick. The thing that sets this apart from multiplication rule is that this is without replacement. So we can't have the same thing multiple times. So like with the ATM PIN codes, you could use the same number multiple times. That would not be considered a permutation. We're just taking a certain number from a pool of options and also putting them in a particular order. So my example here, we're saying a new startup company must appoint a CEO, COO, and CFO. If this is done at random, so they've got 5 startup employees, they want to pick that CEO, COO, and CFO, how many different options do they have? So in this context, they're selecting 3 people from 5 possibilities. And we're putting those people in a particular order because we want one of them to be CEO, one of them to be COO, and one of them to be CFO. So that order is important. We'll see combinations are very similar to permutations, but in that case, we don't take into account the order. So in this case, our n value would be 5, and our r value would be 3. And so the notation from permutations looks like this. We would do 5 and then a p and then a 3, and really it should be with subscripts, kind of like I have in my formula here. So something like this in the middle, you can ignore this little box. It's a lot harder to type these than it is to write them. We can compute this from this formula given here, and then I'll also show you how to do it in Excel, but just so you know what this formula is saying, on the top we're taking 5 factorial, this exclamation point is a math symbol called the factorial symbol, 5 factorial over 5 minus 3 factorial, or that would be 5 factorial over 2 factorial. And so what the factorial means, it's a shorthand way of writing this product. 5 factorial really means 5 times 4 times 3 times 2 times 1. And then 2 factorial would be 2 times 1. So the factorial is you start with whatever number is part of the factorial, so like a 5 factorial, and then you just multiply by every number counting down until you get to 1. So because this is a pretty common operation in counting, we have special mathematical notation for it, and that's what that exclamation point means. So in this case, we would compute this out. I can actually cancel the 2 and the 1 on the top and the bottom of this fraction, so I end up with just 5 times 4 times 3. And the result here would be 60. So there's 60 different ways to select this CEO, COO, and CFO from a group of 5 people if you're just randomly selecting them. All right, so combinations are the same idea. We have n possible choices. We're picking r number of them. But in this case, the order of the choices doesn't matter. So in a similar case as the last one we were looking at, here in this example, we have the same startup wants to assemble a board of directors from among its 24 top donors. So they're going to select 5 people for their board of directors out of a group of 24. But in this case, the order they select those 5 people doesn't make a difference because they just want a group of 5. They don't want like first person, second person, third person. So since this board doesn't have distinct roles to play on the board, this is a combination rather than a permutation. All right, so in this case, 24 would be the n value. That's the total number of possible choices they've got. And then 5 would be the r value because that's how many people they're picking. So I just put that into this formula. If I wrote this out, so 24 factorial, you can write this out with me. This would be 24 times 23 times 22. And then we just keep multiplying all the way down until we get to 1. We've got this great big 24 factorial divided by 24 minus 5, that would be a 19 factorial. So on the bottom, I also have to have 19 times 18 times 17, and again, all the way down until I get to 1. All right, so I've got my 19 factorial down here. You should also see on the screen, I also put in the 5 factorial, which is the other part of the formula down at the bottom. So this is like a big mess of a calculation. This would be a pain to enter into a calculator, although some calculators do actually have a factorial button, which would make it faster. But you should notice that 24 factorial actually contains within it a 19 factorial, because once we count down from 24 to 19, everything else, 19, 18, 17, 16, all of that is the same as what we have in the 19 factorial. So everything here highlighted in the top, and then the same 19 factorial on the bottom, all those highlighted numbers there, they would actually just cancel out. So what we end up with is 24 times 23 times 22 times 21 times 20 divided by 5 times 4 times 3 times 2 times 1. So that's a lot more manageable. And in fact, if you use some cancellation, so for example, I could cancel a factor of 5 out of the 20 on the top. I could cancel a factor of 4 out of 24, say, and so on. If you cancel the factors, you can get this down to a nice calculation. All right, and I put this in a calculator. I got 42,504. So there's 42,504 different ways that you could pick 5 people from a group of 24 people. The reason we're going over these counting methods is that these sorts of counting how many possibilities there are, these come up in probability, And we really need these sort of formulas or methods for counting because obviously you're not going to list out, all 42,000 possibilities in this kind of scenario. So this could enter into a probability calculation where maybe this is the total number of options for picking a certain group. Okay, so because we're using Excel, we're mainly going to use Excel for all of these computations rather than using these two formulas with the factorials in them. So I have in the notes here the two formulas for Excel. Permutations are this permute, P-E-R-M-U-T, and combinations are combin, C-O-M-B-I-N. Both of them have the same order. We put in the N first and then the R. Remember, N is the bigger number. It's the total number of possibilities you're picking from, and R is how many possibilities you're selecting. So just to show you an example, okay, so if I wanted to do my last example with the board of directors, we would do a combination, and we had 24 options with five selections. So that was our N24R5. So I use my combin equals combin 24 comma 5, and this gives me 42,504, which is the same thing that we got from the formula. All right, so you should definitely use these on your homework and on quizzes and things like that. If you have a graphing calculator, they usually have a permutation and combination button option as well. So if that's something you'd like to use, you could do that. But the main challenge with this section is going to be choosing a counting method. So when you have a particular scenario, deciding, am I going to use a permutation, am I going to use a combination, or am I going to use that multiplication method? So there's really two questions you need to ask. One is, can you repeat possibilities? So if you can repeat options, like with the board of directors, if you could have the same person selected multiple times, then that has to be a multiplication rule. So if you can repeat possibilities, you have to use the multiplication rule because permutations and combinations assume that selections can only be picked once. It's sort of without replacement. If you can't repeat possibilities, we could potentially use any of them. So then we'd go to the second question. Second question, does the order of the selections matter? So this is really kind of trying to determine whether we would want to use a permutation versus a combination. So permutations, the order does matter. Combinations, the order doesn't matter. So if my order does not matter, then we would use a combination. If it does matter, I'd use a permutation, or you could actually use the multiplication rule here as well. There is an overlap between permutations and the multiplication rule, but the permutations are usually a little bit easier to compute, so that's what I would recommend. I did put a little note in here to the notes. If you can repeat options, so your answer to the first question is yes, but the order doesn't matter, we don't actually have a counting method for that. None of these three would work in that case. So you shouldn't see that happening in any of the homework problems, but just something to be aware of. That would be a different method of counting. Okay, so the next part of the notes here, there are a bunch of practice problems. And what I'd like you to do is pause the video right here, go through these problems and just ask these two questions. Can you repeat possibilities? Does the order of the selections matter? And decide which of the three methods would you use for this problem. This is usually the hardest part of these questions, is trying to decide which method to use. So go through all the questions. Don't worry about actually computing the numbers, but just decide which of those options would be the appropriate one. So go ahead and pause the video here. When you come back, I can go through the answers. Okay, so question number 1, Sharon is guessing on 8 multiple choice questions. Each question has 4 choices, so we're looking at, A, B, C, or D. In this case, you can repeat options because just because you selected option A for the first question doesn't mean A can't be an answer for the second question. In fact, if it was, you'd run out of options since there's only 4 for each one. So this would have to be a multiplication rule because we can repeat options. For number 2, we're looking at telephone numbers. Again, here in a telephone number, you can repeat digits. It doesn't have to be all different digits. So this would also be a multiplication rule for the same reason. Number 3, since you're creating a playlist, you wouldn't want the same songs playing over and over, so we would not use repeats. And the order does matter here because a playlist, it's saying what order you want the songs to be played in. So this would be a permutation, or you could use a multiplication rule if you wanted to. Combination would be if the order did not matter. Number 4, you're picking the 2 horses for the first and second place, but we don't care about the order. So this is going to be a combination. We can't have repeats here. The same horse can't be in first and second place, but we don't care which one is first versus second. So this would be a combination. Number 5, you have to think a little bit about combination locks, and maybe you had one in high school or something like that. As far as I know, you can have repeat numbers in combinations. So I said multiplication rule here. If you think that you can't repeat numbers, and maybe that's the case for some combination locks, then you could definitely go with a permutation in this case. The order of your combination definitely does matter, so we wouldn't actually want combination, even though it's called a combination lock. The order is important. So multiplication rule or potentially permutation if repeat numbers are not allowed. Number 6 here, this is actually kind of a tricky question because Powerball includes 2 different parts. So the first part of it is picking the correct 5 numbers between 1 through 69. This would actually be a combination. The order you pick numbers in a lottery like this, the order doesn't matter. You're just selecting 5 from that list, and you have to get the 5 right ones. You can't pick duplicates, so there's no repeats. And then the second part is finding the correct number between 1 and 26. So that's kind of a separate possibility. That one's easy to count since you're just picking one number. There's only 26 options. But for the actual counting here, you're going to find the number of possibilities for the first part, the combination part, and then that 26, and you'll actually multiply them together. So it's kind of a combination between a multiplication rule and these 2 separate counting questions. Number 7, this is another phone number question. This is again going to be a multiplication rule because we can repeat options. So now that we've selected methods, I would go through, let's do the multiplication rule ones first. And for each of these multiplication rules, first write out, if I was going to write out my selections, how many selections are there? So how many little slots or blanks should I write out on my paper? So for number 1, for example, she's answering 8 questions and needs to pick an answer for each one of those. So I would want 8 little slots to fill in. Right, so I would draw out 8 little slots on the paper, and then for each one of those slots, you need to decide how many options are there for the first question, and then the second question, and the third question, and so on. And whatever those numbers are, you want to multiply them all together and get your final answer. So let's do all the multiplication rule ones first. All right, so number 1, you should have 8 different slots to fill. There are 8 questions to answer. Each question has 4 choices, so that's 4 times 4 times 4 times 4, 8 times. So that would be 4 raised to the 8th power if you're going to enter that in the calculator. And this comes out to, I believe, 65,536. That would be how many options she had to answer. Now, there is a probability question attached to this. So this is the total number of possibilities she's got to answer this quiz. What's the probability that she gets all the questions right? Well, there's only one possible way she could fill out the quiz that gets all of them right, because she'd have to pick the correct answer for all 8 questions. So that would be 1 out of 65,536. You could turn that into a decimal if you want, but that is going to be the probability that she gets all the questions right. Very unlikely. Number 2, we're looking at a phone number without the area code. So there are 7 digits that we have to select or pick. So you should have 7 slots in your write-out. The first number of your telephone number cannot begin with a 0 or 1, the problem says. So that means that there's actually only 8 possible digits left. So the first option is only 8 possibilities, but the other ones we can use any of the digits 0 through 9. So we've got 10 options for each of those. So I've got 8 times 10 times 10 times 10 times 10 times 10 times 10. So 6 tens and an 8. This would be 8 million possible telephone numbers. I skipped over 3 and 4 because those aren't multiplication rules. Number 5 are combination lock. So I'm assuming typical combination locks have 3 numbers that you have to put in. So I put 3 slots, and there are 50 possibilities on this particular combination lock because we can have the numbers 0 through 49. So 50 times 50 times 50, or we could do 50 cubed. This would come out to, I believe, 125,000 possible combinations. Again, if we are not allowed to repeat numbers, then we could do this with a permutation. In that case, you're going to end up with fewer possibilities, but that potentially could be an option here as well. All right, last one, number 7. This is another phone number question. In this case, you're just talking about trying to guess the last 4 digits. So there should just be 4 slots in your multiplication rule. Each of those 4 digits has 10 possibilities. Because these aren't the beginning of the phone number, we didn't have to limit the 0 or 1 or anything like that. So this is 10,000 options. And again, this particular question also asks about a probability. So there's 10,000 different options if you're just randomly guessing those last 4 digits. If you had 10 tries, what's the probability of getting it correct? In a basic sense, we basically have 1 out of 10,000 possibilities in 1 try. So I said that the probability is 10 out of 10,000. This probability isn't exactly correct because when you're guessing, for example, if you guessed it correctly on the second try, you're not going to keep trying 8 more times. So this isn't exactly right for probabilities, but this gives us an approximately correct answer for this question. Okay, going back up, we need to answer these other ones that weren't multiplication rules. So for example, number 3, the permutation, we can compute this in Excel. I'm going to use that permutation function. We just have to decide what is the n and what is the r. So how many, what's the pool of possibilities that I'm selecting from, that large number n, and then how many things am I selecting, the r. So number 3, for example, the pool of possibilities would be 50. There are 50 songs that you're picking from here, and we're selecting 12 of them for this playlist, so our R value would be 12. So go ahead and go through for the permutation and combination ones and fill out what those options would be. All right, so I computed these in Excel. Number 3, this is the permutation 50, 12. You'll notice that this result is showing in scientific notation 5.8, and then this e plus 19, that means times 10 to the 19th power. Really what that means is that the decimal point next to that 5 needs to go to the right 19 places. So this is a really, really large number. One way to easily convert this is if I change the formatting in my number formatting spot just to number, it will write this out as a full number and not in scientific notation. So I'm not going to retype this in my notes, but this would be our answer for that one. Huge number of options. Number 4, this was from the horse bet. This is a combination 19, 2. There were 19 horses running. We have to pick the top 2. So there's 171 options for that. Now, number 4 did ask what would be the probability of winning this bet picking at random. So we know that there's 171 options total. Only one of those options is correct though, so the probability of winning would be 1 out of 171 possibilities. Number 6, this is a combination, this is just for the first part, but 6, choose 5, so or 69 possibilities, picking 5 of them. This is about, let's see, 11 million here. This is just for the first part of the lottery though, so I mentioned the other part because there's 26 possibilities for that second piece. We need to then take the product between the number of ways we can pick the first set of numbers times the number of ways we could pick the second set, which is 26. So I'm going to do a multiplication between this result and 26, and this gives me this number here, which would be my total number of options for winning the lottery or for playing the lottery. All right, so here's my total number of possibilities. Again, we have a probability question here. The probability of winning the jackpot, you have to get all of those numbers right to win the jackpot. So that would be 1 out of, again, that total number of possibilities. So this is 1 out of almost 300 million, which is a very small probability of winning. All right, that's all the examples. So you've got some homework from 4.4 to work on, and that'll be it for this video. Thanks. Have a good day.